Hi everyone. Good morning, good afternoon, and good evening. I am Asma Shindi. I'm a petroleum engineer who recently graduated from American University of Ras Al Khaimah. On behalf of BioPetro, Arab Oil and Gas Academy, and SPE Egypt section, I would like to welcome all of you to the third session of our short course, an overview of multi-stage completions for hydraulic fracturing, presented by distinguished speaker, Engineer Aaron Burton. Our course consists of 4 webinars, 4 quizzes, and a final exam. The certificates will be provided only in case if you have passed the quizzes and the final. So good luck. Before I present our speaker, I would like to remind you that if you have any questions, please keep them in the Q&A box. Now, our speaker is Aaron Burton. His career has been focused on the completion of shales and similar unconventional plays that require multi-stage hydraulic fracturing. In 2015, Burton started Unconventional Oil and Gas Training, a company specializing in training and consulting for unconventional multi-stage completion. Unconventional oil and gas training provides in-house and video-on-demand training courses and performs projects including market studies, due diligence, reports on specific tool segments, and other projects. He also remains an active instructor and participant in industry. Please welcome Aaron Burton. Aaron, the mic is yours.
Thank you, Asma. So yeah, before we get started today on day 3, just a couple of reminders. You can check out other free content that's not in this course on my website at uog.training in the form of my video blog or free training course. And also, please be sure to subscribe to my YouTube channel. So I put content on them right now. I'm actually getting ready to record some new videos, things like that. So if this is a subject that you enjoy, that you're passionate about, and you find my resources valuable anyway, be sure to check out those 2 venues as well. So we're going to pick back up where we left off with plug and perf on day 2 and go over the other 2 primary completion systems for these unconventional reservoirs. So the next system we'll talk about is the ball activated completion system. And we'll start by looking at a well overview. So we already have our horizontal well drilled in our target reservoir. We have our intended completion ran at the depth. And some of the key components we're going to have, or the 2 primary components, are going to be open hole packers, and that's going to provide our angular isolation. So at least initially, these were designed as open hole completion systems rather than cemented like we saw with plug and perf. The other key component is the ball activated frac sleeves. Now some of the other components that are kind of secondary components is going to be the casing packer. And the reason I consider that secondary component is because it really, as long as that packer can hold up to the weight of the completion below it, as well as the pressures and temperatures during the frac job, you really can run whatever packer you want there. You can run a liner hanger, you can run a permanent packer, sand control packer, premium packers, or really whatever's cheapest and most readily available in your area. Now, to give you some of the nomenclature here, you'll see that this is a toe-to-heel fracturing again. So the first stage in the system is going to be stage 1. It'll be at the toe of the well, and then you work your way back up the wellbore. Now, and just to kind of give you a reference as well, these are installed with the drilling rig using your casing string. So if you have your open hole packers spaced out, then you're going to so each joint of casing is roughly 40 feet. So let's just assume we want 80 feet of spacing between each of our tool components. So we would run 2 joints of casing, 80 feet. We would make up this open hole packer to the casing. And then we would run another 2 joints of casing directly to that packer. And then our frac sleeve, another 2 joints of casing and for 80 feet. And then another open hole packer. And you would just repeat that process. So you're actually going to run it with the drilling rig, spacing out in the well as you want to, as your frac design calls for. And then once you've installed the system, then you can do all your setting that we'll go through right now, do your pressure testing, and then you can move your drilling rig off of location. So the first setup we'll look at is the fluid activated packers. So once you've got your completion to the intended depth, you pump your activation fluid through your tubing, through your casing, into the annulus. And then once you've spotted that fluid, you can set your casing packer. And once your casing packer has been set, then you can pressure test, ensure that everything is set, and you move your drilling rig off of location. Now over time, packers are going to react with that activation fluid. They're going to swell out, and they will contact the target reservoir, and that's what provides your annual isolation between each sleeve. Once you're ready to begin fracturing, you bring out your frac crew, you drop the first ball in the system, pump it down hole to the first sleeve, and once it gets on seat, you apply pressure, shift that first sleeve open, and you can begin fracturing your first stage. The other type of setup for these, the ball activated completion system, is using hydraulic set packers. So once again, we already have our well drilled, we have our completion system in the wellbore. We're using the casing to space out just like we did before. And now, but these are hydraulic set packers in this scenario. So once you get to the intended depth, you're going to have one or two additional tools at the toe of the well. And the first one is going to be the isolation tool. What that allows you to do is when you're running the system in the wellbore, you can still circulate through your casing. And but then once you get to the intended depth, you drop the first ball in the system, pump it down hole. And once it lands on the isolation tool, you apply pressure, it shuts off, and now you have isolation through your tubing. So once you've done that, that allows you to set all of your hydraulic equipment in the wellbore. So you'll continue raising your pressure. And these pressures are a staggered pressure. So just to use some good, clean, round example numbers, maybe at 1500 PSI, your casing packer will set. So you raise your pressure up to 1500 PSI, set your casing packer, and then maybe your open hole hydraulic set packer set at 2500 PSI. So you continue raising your pressure to 2500 PSI and set your hydraulic set packers. And then the second piece of equipment at the toe that's different is going to be your pressure activated frac sleeve. So remember that as soon as you've set this isolation tool, you no longer have the ability to pump into your target reservoir. And above it, these are the ball activated frac sleeves. So you're very limited as to what you can do through tubing. So a tubing conveyed perforating run is not an option in most cases. So this is a pressure activated frac sleeve that will open when you apply the right amount of pressure. So if we set our casing packer at 1500 PSI, our open hole packers at 2500 PSI, then your pressure activated sleeve may be set at 5000 PSI. That way you can set all of your hydraulic equipment, you can do all your pressure testing, and then once you confirm that everything's holding, you can move your drilling rig off a location, and the pressure activated frac sleeve remains in the closed position. Once you're ready to begin fracturing, bring out your frac crew, you apply that 5000 PSI, the pressure activated sleeve shifts open, and then you can begin fracturing your first stage. Now, once you finish fracturing your first stage, it doesn't matter which setup you're using as far as the fluid activated packers versus the hydraulic set packers. The fracturing procedure is the same. So we'll zoom in here to the second sleeve of the well. So overall, these are a very simple conceptual design. You've got a frac sleeve made up to your casing, and you have frac ports built into that sleeve. So if we look at a cutout view, behind that, you're going to have an insert that's going to be covering up the frac ports in the closed position. And it also has a ball seat profile in that insert. So as we're fracturing stage one, we're going to be pushing our fluid and proppant through all of the ball seats above it. Now, as we finish it up fracturing stage one, we're going to drop the ball that corresponds to the second sleeve, pump it down hole. Once it lands on seat, we apply pressure, it shifts the sleeve open, and then you can begin fracturing your second stage. So when the ball lands on seat, it provides the through tubing isolation from the previously fractured stage, and it forces the fluid to divert out of the ports in this second sleeve. So if we move up the wellbore to the third sleeve, as we're finishing fracturing our second stage, we're going to drop the ball that corresponds to this third sleeve. We pump it down hole, it lands on seat, apply pressure, shift the sleeve open, and the fluid is diverted out of our third stage now. So you don't actually ever have to shut down your frac job during the pumping process. You just have to drop the ball in, pump it down hole to the next seat. Now, it's a little bit difficult to see in this animation, but each of these balls gets larger as you go up the wellbore. So starting at the toe of the well, you're going to have the smallest ball of the system, because that smallest ball has to get through all of the larger ball seats above it. And then they get incrementally larger as you go back towards the heel. So the smallest ball at the first stage of the well, and the largest ball at the heelmost stage of the well, the final stage. Now, just to kind of give you an idea of where or how many stages you can have with this type of system, a large majority of these systems are run in applications where there's 4.5-inch casing. And most of those systems are going to be on the US side of the Bakken or Canadian plays. So with the 4.5-inch casing, if you need about 10,000 PSI, then you're going to be limited to about 40 stages with this system. But if you're in a position where you can go less than 10,000 PSI, less than 5,000 PSI, you can get up to 60 or 65 stages with this type of system, assuming that you're using the Openhole system we're discussing here. It's a little bit different in the cemented system that we'll talk about here in just a minute. So after this, you're just going to repeat the process of fracturing. So as you're finishing up fracturing your third stage, you drop the ball that corresponds to that fourth sleeve, pump it down hole. Once it lands on seat, apply pressure, sleeve shifts open, and you fracture the fourth stage. And then without ever having to shut down your pumping, you drop the ball that corresponds to the fifth stage, pump it down hole, pressure up, open the fifth sleeve, and begin the fifth stage fracture. So this has really been one of the highlights of this type of system, is because it's very, very efficient at surface, because you don't have to shut down your pumping between stages. It's at least if everything goes correctly, then you're going to have nonstop fracturing operations. So we'll zoom back into an individual sleeve to talk about the post-frac operations. So we're going to produce our hydrocarbons through the fractures that we've created, and then back through the ports in the sleeve where we fractured out of. So not only are the sleeves the conduit for the frac job, they're also the conduit for the production as well. Production from below the sleeve will push that ball off seat and back towards surface. And in a lot of cases nowadays, those are also the dissolvable frac balls. So very similar to the dissolvable frac plugs we saw yesterday. The frac balls are typically dissolvable alloys, and they'll disintegrate and remove themselves from the wellbore just in the fluids that are in the well. And that way they don't stay in the wellbore, they don't get caught up in the wellbore, and especially in oil plays where there's not enough velocity to bring those balls back to surface, that can be a good feature to have. The other thing about the dissolvable alloys is they actually add a lot of strength. So a lot of the 40 stage, the 60 stage that we were referencing, that really was unlocked because of these alloy balls having additional strength. Now you do have a excuse me. So this is an interventionless system. You don't have to do anything after the frac job. You can just produce through it like we're showing here. But as you see, these ball seats have a diameter restriction. So if that's an issue, it is possible to go in and mill those ball seats out and get a near full wellbore diameter afterwards. So the ball seats are designed, they're mostly cast iron, and they're designed to be as short and compact as possible and easy to mill out. So it can be an interventionless system with diameter restrictions, but you can go in and intervene afterwards and get your full diameter again. So this is a case history from the US side of the Bakken. So this is from 9 Energy Services. And this is really just highlighting the efficiencies with this type of system. So if I recall correctly, this is a case history from 2013. So it's a 50-stage system, the 4.5-inch liners that I was talking about. And you can see all of the remaining frac job details there. And by today's standards, this is a very small frac job, at least in the US. So, so keep that in mind as well. But to stimulate this 50-stage well, they had 51.2 hours total time. So that's from opening the wellhead to begin fracturing to shutting it back in. Now the actual pumping time was 46.7 hours. So overall, they were able to pump a 50-stage frac job in 46.7 hours. And they also had non-productive time of 4.5 hours. I don't know for sure what it was, If I had to guess, I would guess it was something along the lines of pump maintenance or something like that. But overall, this case history just really shows how quick and how efficient these systems can be at surface. So another alternate to the open hole system is the cemented ball activated frac sleeve systems. So overall, the fracturing procedure is virtually the same, but your wellbore construction is going to be different. So instead of having packers between the sleeves, now you're going to pump cement through the casing into the annulus, and that's what's going to provide your annular isolation. So once again, at the toe, we're going to have a cementable pressure activated frac sleeve. So once you've cemented it in place, you've done your pressure testing, you move your drilling rig off of location, and once you're ready to begin fracturing, rig up your frac crew, apply the right amount of pressure, and the first stage sleeve will open, and then you just drop the balls in the correct order, just like we saw with the open hole systems. But it is very important to consider in the wellbore construction, you have a couple of additional components. So when you're cementing a well into place, you pump it through your casing, your cement through your casing, and you're going to follow that with a cement wiper plug, which does exactly what it sounds like. It wipes the cement out of the casing so that you don't leave any cement stringers behind, and it pushes the cement into the annulus. Now, it's no different when you have the frac sleeves, except for now you're pumping it through those reduced diameters in the ball seats. So you still have to pump your cement through the casing, through all of these ball seats, and then you have to follow it with the cement wiper plug so that you know that the cement isn't remaining in your casing and hindering your completion. Now, so it is very important to consider that, because with this cement wiper plug, you can't have it get hung up in your ball seat and prematurely open the sleeve. Otherwise, you're going to open the sleeve and dump all your cement right back into your casing. So there is a diameter restriction with the cemented frac sleeves. So generally speaking, obviously it depends a little bit on which service company you're using, but generally speaking, you're limited to a 2-inch diameter ball seat being the smallest one you can have in the system. And what that translates into is typically 25, maybe 30 stages at max with these cemented sleeves. But there is also another technology that allows the cemented sleeves to have multi-entry points. So with these sleeves here, the overall wellbore construction looks very similar to the regular cemented sleeves we were looking at. But now these are multi-entry sleeves here. So you're still going to drop balls in order, but the difference is going to be each ball opens multiple sleeves. So in this case, we're looking at 3 sleeves per stage. So we drop our first frac ball, it'll open this sleeve, pass through, open this sleeve, pass through, and then open this sleeve, and it stays like a regular ball seat, opens this sleeve and isolates from below, and now you fracture out of each of these sleeves individually. You drop the next size ball, you do the same thing for the next stage, and then you drop the next largest ball and do the same thing for the next 3 stages. Now, as we saw with the multi-entry balls, frac sleeves, what that allows you to do is start mimicking plug and perf in multiple clusters with plug and perf. And because of this feature, in a lot of cases, you're going to see these multi-entry sleeves have adjustable frac ports. So instead of having kind of the fixed frac ports we saw before, these are going to be ports that you can adjust. So you can block some of them off if you want less flow area and you're trying to do a limited entry perforating strategy, or you can make some larger if you wanted to, or smaller. So you have full capability to adjust and use these types of sleeves in a very similar fashion that you would clusters with plug and perf and do any limited entry strategies you may have as well. If we look at the cutout view behind it, it's very similar to the traditional sleeves. You have an insert covering up those ports when it's in the closed position, and it has a ball seat profile in it. But with these sleeves, once the ball lands on seat, you apply pressure, shift it open, and now there's a slot in the back side of the sleeve that allows that ball seat to subside, and then the ball can keep moving down the wellbore and opening more sleeves. So that's what gives it the ability to open multiple sleeves with one size ball. Now, a big part of the reason why they're designed very similar to plug and perf is because that's where most of these types of sleeves are ran right now, is more of a hybrid system with plug and perf. So they'll run these multi-entry sleeves at the toe of the well, and then they'll drop balls in the correct order to open the sleeves. And then once they're finished doing that, they'll switch back to traditional composite plug and perf perforation or fracturing operations. So once they finish those, they go back to their plug and perf assembly, finish up the well. And the reason they do this is because it typically in longer laterals where they're trying to do plug and perf within their safe operating range of coiled tubing, but then want an interventionless system outside of their coiled tubing range. So this allows you to use plug and perf in longer laterals, just like we saw the other day with the dissolvable plugs. You run those at the toe because it's interventionless, and you don't have to risk mill out operations in those longer laterals. So one of the newer technologies with these types of sleeves are frac sleeves with counter mechanisms. And there's a lot of different ways to do this. Several service companies do have some of these sleeves available now. And the version we're going to look at here is really based purely on mechanical motion. So we have 5 sleeves here. The yellow number tag, that's the counter on the sleeve. So we drop a ball, and each time the ball passes through a sleeve, the counter counts down 1. So when the ball gets to sleeve 0 is in the set position. So you can apply pressure, shift that sleeve open, and then you can apply and begin fracturing in the first stage. Now you're going to drop the exact same size ball again, and it's going to count down, but now the second sleeve in the system is on the 0 counter and in the set position. So once the ball gets there, it catches, you apply pressure, shift the sleeve open, and begin your second stage fracture. And then you're going to drop the exact same size ball again, and it counts down, but now the third sleeve is at the 0 count and in the set position. So it catches it, you shift the sleeve open, and you begin fracturing your third stage. So, like I said, there's a handful of service companies. I think my last count was maybe 8 at this point that offer a version of this type of sleeve. And it can be purely mechanical motion that counts. It can also be electronics in the sleeve that count. And there are some versions that use a mechanical and electrical components to be able to count the frac balls as they pass. So the benefit of these types of sleeves is you get a virtually unlimited number of stages with a minimal diameter restriction, or in some cases with the electronic sleeves, you might not even have a diameter restriction because when the electronic sleeve, you're not relying on a ball seat diameter. So that's the whole point of these sleeves here. That's the innovation, is trying to get that virtually unlimited number of stages with minimal or no diameter restriction. Another alternative to that's trying to accomplish the same thing with a virtually unlimited number of stages with minimal or no diameter restriction is the ball seats with a collet locator. So we're looking at a cutout of a sleeve, but you can see it's a little bit different than what we've seen before. We have this insert, but it doesn't have a ball seat in it. Instead, it has a profile built in. So what this system allows us to do is we can actually pump the ball seat into the well and into the into the insert. So on the insert, instead of having a ball seat, we have a collet profile, and then the ball seat itself that we're pumping down hole has a collet on it. And just to clarify, this is not with wireline. This is pumped down just the ball seat itself. And the way you're able to do that is you already have the ball on seat as well. So that gives you enough surface area that you can pump that assembly down hole without it having to be on wireline. So now, as you can see here, the collet and the collet profile do not match up. The collet's too big for this collet profile. So it continues pumping down the wellbore. As it continues moving down the wellbore and it comes to the seat that it correlates with, then that collet will snap into the profile, and then now the ball seat is placed in the frac sleeve. Now, if we look at the cutout, like I said, this is just the ball seat itself, but the ball is already on seat. So once we flash in the sleeve, we're going to apply pressure, shift the sleeve open, and we expose the frac ports, and it looks just like you would with a traditional sleeve now. Now, once you're finished fracturing, the ball will dissolve, remove itself from the seat, and because you're actually placing the ball seats in the wellbore, you can use the same size ball seat over and over again. So you're going to choose the largest size ball seat, and so you can do one of two things. You can either consider it an interventionless system and produce through that large profile, or if you think that that's going to be a problem, then you can go in and remove these ball seats with the collets with through tubing intervention. So you run in your through tubing tool, you expand it out once you get past the seat, and then you can pull up the wellbore and drag the ball seats back out of the well. So that's the ball activated completion system. The next system that we're going to discuss is going to be the coiled tubing activated system. And we're going to start with the setup that's not really commonly used now. A couple of Canadian operators still use this setup, but for the most part, these systems are set up with sleeves. But you'll see here in a minute why it's important to understand using it with the Sand Jet Perforator. So we already have our horizontal well drilled. We're going to run our casing in with our drilling rig. Once we get to the intended depth, we pump cement to provide annular isolation. So overall, the wellbore construction looks identical to plug and perf. It's just a cemented casing string in the wellbore. Once you've pumped your cement, you've done your pressure testing, you can move your drilling rig off a location. So if we zoom into the toe, once we're ready to begin fracturing, we bring out our pressure pumping and our coiled tubing unit. And our coiled tubing assembly will consist, of course, of coiled tubing. And then there's going to be several other components, but the two primary components are going to be a coiled tubing packer and a Sand Jet Perforator. So once we get to the intended depth, we're going to set our coiled tubing packer, and then we're going to pump an abrasive slurry through the coiled tubing and out of the Sand Jet Perforator. So this is going to create an abrasive perforation. It's going to cut through the casing, through the cement, and into the target reservoir. And once you're finished Sand Jet perforating, you shut down your flow through the coiled tubing, and then you're going to pump your frac job down the annulus and out of the perforations that you've created. Once you're finished, you unset the packer, and then you can move up the wellbore to the depth of your second sleeve. So once you've located the depth of your second, the depth of your second stage. Once you're to the depth of your second stage, you reset your coiled tubing packer to isolate from below, and then you're going to pump that the fluid and proppant, fluid and sand through your coiled tubing out of the Sand Jet Perforator and Sand Jet perforate your second stage. Once you're finished, shut down your flow through your coiled tubing again, pump down the annulus to fracture your second stage, and then you're just going to repeat that process. Now, a lot of times you're going to hear the coiled tubing activated completion systems called annular fracturing. And the reason being is because you're pumping the frac job through the annulus between the coiled tubing and the casing. So if you ever hear someone refer to annular fracturing, that's what they're referring to, is the coiled tubing activated systems. So you shut down your frac job after you finish fracturing your second stage, pull to release your packer, and then you can move up the wellbore and just repeat that process until all the stages in the wellbore are finished. You just locate the depth of your next stage, Sand Jet perforate, fracture down the annulus, and then just do that until all stages are fractured. Now, the most common way to set up the coiled tubing activated system is the frac sleeves. So we've got our frac sleeves already in the wellbore, made up to the casing string, just like we saw with the ball activated system. So just to recap, to show you, if you're not familiar with rig operations, each casing joint is 40 feet again. So if you wanted 80 feet between each stage, then you would run a sleeve, 2 joints of casing, and a sleeve, 2 joints of casing, and a sleeve. So that's how you space that out with your casing string as well. Once you get to the intended depth, pump cement to provide isolation to the annulus. And then once you're finished pumping cement, you do your pressure testing, you can move your drilling rig off the location. Once you're ready to begin fracturing, bring out pressure pumping and coiled tubing, and you're going to run your coiled tubing assembly into the wellbore. Now overall, the assembly looks very, very similar to the Sand Jet Perforator that we saw before, even though the Sand Jet Perforator is not the primary means of diversion in this setup. And we'll look at some of the benefits with having this setup. So we locate our first sleeve, we open it, and we begin fracturing down the annulus. Pull to release the packer, locate the second sleeve, open that sleeve, and fracture down the annulus. And then pull to release the packer, locate the third sleeve, fracture, and then just repeat that process until you finish fracturing all the stages. Now, one of the immediate initial benefits of the Sand Jet Perforator is it does give you some flexibility during the frac job to adjust stages on the fly. So if you decide that you need to add an additional stage between this sleeve and this sleeve, it's possible to do so with the with the Sand Jet Perforator. So you pull to release the packer, locate the depth of the stage you want to add. You pump down the coiled tubing through the Sand Jet Perforator, create the abrasive perforation, and then you can add that stage into the system. So there's a couple of different options with these frac sleeves. The first one and the most common one used is the pressure open frac sleeve. So we've zoomed in, we have to one of the stages, we've got a cutout view of the sleeve, and you can see that there's an insert in the frac sleeve. So what we do is we pull up with our coiled tubing, we locate that insert, we set our coiled tubing packer into that insert. So now the slips on the packer have actually gripped in there. So that allows you to translate pressure into force against that insert. Because that packer is isolating, the pressure turns into force, and it shifts that insert open and exposes the frac ports so that you can fracture out of those frac ports. And then, of course, the coiled tubing packer will isolate through tubing between the previously fractured stage. The other option of frac sleeve is the pressure balanced frac sleeve. So with these sleeves, you're going to have a couple of ports on the sleeves. So you go in, you locate the sleeve, you're going to set your coiled tubing packer in between that sleeve, or in between the ports on the sleeve, and then you apply pressure. So with this setup here, with these types of sleeves, you have an upper port and you have a lower port. So now the coiled tubing packer has isolated, and the pressure is only seen by the upper port, whereas the pressure is not seen on the lower port. So that creates a pressure imbalance and allows that sleeve to shift open. So let's assume that we're applying 5,000 psi from surface, and we don't really have any pressure to speak of below us. So that 5,000 psi pressure imbalance allows that insert to shift open and down hole. And of course, the coiled tubing packer isolates from the previously fractured stage as well. Now, all the other sleeves in the wellbore do not have that coiled tubing packer isolating. So the upper and the lower ports on those sleeves both see 5,000 psi, so they remain in a pressure balance position and in the closed position. So most of the sleeves used nowadays have switched to a frac sleeve locator because it's just a lot easier and a lot more accurate to locate the frac sleeves. Because as you saw on both of the designs of the frac sleeve, whether you're setting your packer in the insert and then applying pressure, or whether you're setting your packer between the ports and applying pressure, it's very critical that you know exactly where your assembly is with these sleeves. So that's where the frac sleeve locator comes into place, because you'll have a profile that's built into your frac sleeve here, and then the coiled tubing assembly will have a locator on it that snaps into place or locates that sleeve. And that way, you space out your coiled tubing assembly so that you know that your packer is in the right place in that sleeve to either grab the insert or to isolate between the two pressure ports. So if we zoom back in and look at fracturing operations, it is once again annular fracturing, fracturing down the annulus between the coil tubing and the casing and out of the ports we've opened, and your coil tubing providing the through tubing isolation from the previously fractured stage. Now, when we're doing that, we're applying a collapsing force on our coil tubing. So in the fracturing operations, in most cases, actually in all cases, as far as I know, we're actually going to pump a little bit down the coil tubing as well. Now, it's going to be a very low rate. Depending on how you set it up, in most cases, it's not going to actually be contributing to the frac. But one of the primary things that it does is it puts a pushback force on that collapsing force and helps protect your coil tubing from collapsing. Now, one of the unique advantages here is that this is what's called a dead leg pressure reading. So when you're measuring your pressure at surface through the annulus where you're fracturing, you've got you've got turbulent flow first off, then you have a lot of friction losses because your fluid and proppant is going against your coil tubing and your casing. So the pressure you're reading at surface is not actually what's happening here at the injection point. But you have laminar flow through your coil tubing, you have this access point through your Sand Jet Perforator, and so because it's laminar flow, what the pressure reading through the coil tubing is very, very close, if not exactly, what the pressure is downhole at this injection point. So that can be very handy in preventing screen outs. So as we talked about on our first day, a screen out can be very detrimental in these operations because it can cause you to shut down because you no longer can pump into your wellbore. So when you have live pressure monitoring through that dead leg pressure reading, then once you see those pressure spikes or the pressure rising, you can adjust your frac job accordingly and try to avoid the screen out in the first place. But if you are in a situation where you do screen out, maybe you just didn't catch it in time or it just popped up on you all of a sudden, if you do screen out and you can no longer pump into the wellbore through the annulus, your proppant's backed up in your casing, there's an automatic contingency option built in because of that Sand Jet perforator. And in some cases, you might even have the option of opening a circulation sub. So what you can do with this in this situation, you pull to release the packer if you possibly can, and that'll allow you to move your coil tubing at least down the wellbore. You can shift it up and down, but you have the ability to circulate fluid through your coil tubing out into the annulus, and you have the ability to clean out that excess proppant from your casing, and then you can move on to the next stage. So if a screen out does occur with this system, it is hands down the best contingency option because you already have coil tubing in the well at the depth of the problem with the ability to circulate through coil tubing and back to surface. So one of the newer technologies for this type of system is reclosable sleeves. And there's a lot of different potential applications for these. And one of the first ones is to use them in the primary frac. So what you can do with these sleeves, you go in, you open them just like you typically would, shift the sleeve open, and you fracture that stage. But right after you finish fracturing, you shut down your frac job, and you can reclose the sleeve immediately. You go up hole, locate the second sleeve, and you do the same thing. Open that sleeve, fracture your second stage, and then once you're finished fracturing your second stage, then you can reclose that sleeve. And you just do that for every sleeve in the well. After you're finished fracturing, you go in, reopen all the sleeves, and you put the well on production. Now this particular application here is going to be very formation dependent. So what you might see those sleeves used for is an application where your formation takes a few hours or maybe even a few days to close back on the fracture you've created. Because until that force from the formation tries to close in on your proppant and hold the proppant in place, then the proppant is more or less free floating, if you will. So what can happen there is once you bleed off the pressure after you're done fracturing and you move off to your next stage, then that proppant near the wellbore could flow back into the well, and now that could hinder your production because now you've lost your near wellbore conductivity at that stage. So that allows you to help help the formation, give the formation time to close on the proppant and hold it into place and get overall better near wellbore conductivity. So once again, it really just depends on your formation, how quickly it's going to close. I know I've talked to a Canadian operator that in one of their plays, they had a lot of success with this sleeve. They, just to kind of give you some reference, they used to use the non-closing sleeves, and then they would go and do a clean out trip afterwards, and they would remove a lot of excess sand because the sand was just falling back in. And if I recall correctly, I think they estimated that it took, I think it was maybe 10 hours for their formation to close and hold the proppant into place. And so they tried these types of systems, and once they went back in and reopened the sleeves, they had virtually no proppant fall back into the wellbore. So they considered it a very good success. Now, the other unique thing about these sleeves is when you reclose them, you re-isolate your wellbore. And so every system we've looked at so far, it is limited to toe to heel fracturing. Because if you're doing plug and perf, you can't perforate at the heel and then go below it because you don't have a means to isolate it. With either of the frac sleeves, you can't open the sleeve at the heel of the well first and then go below it because you have that open exit point. So you're limited to toe to heel fracturing, but these reclosable sleeves give an interesting option to do out of order fracturing. So you can go in, we'll just start at the first sleeve, open it, fracture, and then reclose it. And then for our second stage, we go to our third sleeve in the system. So we open it, pump down the annulus to perform the frac job. Once we're finished, we reclose the sleeve. And now, because that sleeve is reclosed and re-isolated, we can move back down the wellbore, still have that annular isolation, and use our second sleeve in the well as our third stage in the overall frac. So we open it, we can go back in, fracture between those stages. And so the theory behind this, behind why you might want to do out of order fracturing, is really kind of playing on stress shadowing effects. So you're fracturing your first stage here, you're fracturing your second stage at the third sleeve, and then you're coming back and placing the frac in between those. So at least in theory, if it works as the theory says it will, with stress shadowing, things like that, you get a more complex fracture network and then therefore better production. So I know a few operators are experimenting with the out of order fracturing. So it'll be very interesting to see what kind of results we have with those. So once you're finished fracturing, you go back in, open all the sleeves up for production. And then once the sleeves are open, then you can produce back through those ports that you fractured out of as well. So as you've kind of seen here, in these types of systems were really initially designed for cemented applications. So the sleeves could be cemented into place without any issue, but they can also be used in open hole applications as well. So really the only thing that's different is the wellbore construction. So instead of running your sleeves and cementing in the annulus, you're going to run your sleeves and place your open hole packers between the sleeves to achieve the annular isolation. So open hole isolation is definitely an option. It was, when these systems came out in 2010, 11, 12, somewhere in there, there were a handful of operators that preferred the open hole sleeves, but to my knowledge, all of these systems are run with the cemented isolation now. But you never know when you might come into a scenario where open hole isolation is the preferred isolation method. And you can also combine these two systems for another hybrid type system. So you can run the ball activated sleeves at the toe of the well outside of the range of coiled tubing, like we saw before. Then that allows you to drop the balls at the toe of the well, fracture the toe of the well, And then once you get within the safe operating range of coiled tubing, you switch to the coiled tubing activated sleeves and can do your fracturing as you typically would with this system. So it allows you to have an interventionless system at the toe, and it allows you to extend out this type of completion in longer laterals. For example, if you go back and look at some of the operator investor reports for the U.S. Bakken in 2013 or so, there was a lot of experimentation with the coiled tubing activated sleeves. And if you read through their report, some of their 105 stage systems actually had about 10 stages of the ball activated sleeves at the toe of the well. So those were actually hybrid completions. So that's it for today. That's the other two types of completion systems with the that complement plug and perf. So at this point, we'll open it up for questions and answers.
Thank you, Erin. This was a very informative session. That we didn't receive any questions just because you explained everything in a clear way.
Well, I guess that's either a really good thing or a really bad thing, right? Everybody's either really confused or it was explained so well there was no need for questions. So
yeah, you explained very well. Thank you so much.
Thank you. Well, if you want to give it a few minutes, any questions that might come in?
Okay, let's do this. Guys, if you have any questions, please ask.
All right. Well, I guess we can assume that everything was well, right?
Well, Evan, let me ask you a question.
Yeah.
So all what you explained to us in your this is your third lecture, right? So all what you explained, is it only related to shale development, or we can apply any of these technologies in let's say in sandstone reservoir or carbonate reservoir or any conventional reservoir?
Yeah, so typically these are used in the shale type reservoirs, if you will, that are, the low permeability, require multi-stage fracturing. So even within, what people slangily call shale plays within the U.S., those can be shaly dolomites, or they can be different carbonates, sandstones, like you're talking about. But the interesting thing is multi-stage completions are used in conventional applications as well, what we kind of consider conventional. And so like with the ball activated frac sleeves, for example, I've seen those used in the North Sea with a more conventional play that's been using multi-stage fracturing since, I believe, the late 70s, maybe the 1980s. And it was common practice for them, but their fracturing process was very time consuming. So what they ended up doing is trying some of the ball drop sleeves because it added a lot of efficiency for them. So it doesn't necessarily have to be these types of plays. Just kind of like anything in our industry, all of this technology really came from conventional applications. We've been using frac plugs for years in the form of cast iron bridge plugs. These were just modified for special occasions.
So we can do the same for tight sand, for example, or coal bed methane, or still this is not similar application?
It all depends on your fracture treatment objective. So if these tools can meet your fracture treatment objective, then yes. And so we actually, when I was still at Baker Hughes, we were looking at it for a couple of coal bed methane applications as well. It's a little bit different there just because of the way you're fracturing coal bed methane. So if I recall correctly, we decided that at least the ball drop sleeves were really probably not the best answer because of the way the formation would collapse after you fractured it. But if you look at Packers Plus's website, for example, they teamed up with Schlumberger in Brazil and kind of combined sand control technologies with the ball drop sleeve technologies. So what they would do with that system, they ran in offshore Brazil. They ran the ball activated type sleeves. They would drop balls to open the sleeve to fracture. And then once the frac job was done, they had the ability to close the sleeve, and then they would open a screen to produce through. So it helped efficiency on the fracturing end, but because of that application, they still required the sand control. So they would close the ball activated frac sleeve and open a sand screen to produce through. So you can kind of take bits and pieces of the technology and combine it for different applications.
Evan, thank you very much for the excellent answer.
Yeah, absolutely. Asma,
Now, thank you,
any
Aaron.
additional questions come in?
No questions.
Okay.
As I said, you explained everything in a very good way.
Well, thank you. Thank you.
Thank you, Aaron, and thank you all. The session will be uploaded on PioPetro YouTube channel, and don't forget to solve the quiz on Google Classroom. Best of luck, and thank you again.
Thanks, everybody. Have a good one.
Thank you.